Hi, welcome back. So we are going through the brain. We're looking at the nervous system, and today we're going to just look at some of the basic the outline of the sensory motor areas. We're going to get into that in a little more detail in the future, a couple extra videos. But I want you to just get an idea for kind of some of the main classes of white matter tracts, meaning like where do all of the communication centers go? Like how are they communicating? And directionality, because directionality is incredibly important and the brain is pretty well organized in that way. And also I want to talk to you a little bit about the idea of lateralization, which is very evolving at this point, but also very helpful in understanding things like different types of neurodegenerative disorders or brain defects, injuries, and also helping us with the healing, repair, and treatment of those specific items. Okay, so let's look at the map. Here is the basic map. So this would be like if there was a sagittal cut, right? So right down like a sagittal cut right down the longitudinal fissure. This is what we would see. And so inside here, this is all white matter tract right here. So we'll talk about these areas in just a little bit. But for now, I just wanted you to look up here in the frontal area. So frontal lobe. So remember we talked about this previously. So it processes emotions, social, personal interactions, logic, one of the logic centers for sure in the brain. And then we have the motor cortex and the somatosensory cortex. So primary cortex, motor and somatosensory cortex. So we'll look at this a little bit later on. There's a really nice like kind of homunculus of the body, which shows you, how all the intake signals and how the outputs kind of go. So they're really interesting. Premotor cortex or association areas are going to be kind of everywhere. These association areas kind of help with the business of cleanup and collateral. So incoming signals are oftentimes processed in these different areas. So some of these association areas also communicate to nearer parts of the brain to help make better choices, perhaps be more predictive. So also parietal lobe is going to carry some more of the somatosensory association cortex. So you notice up here, so premotor is on the side, and then primary is over here, and then again, so this is association cortex over here, right? Let's see what else. Occipital lobe, large vision center over here. So primary visual cortex back here, like right. So here's your eyes are on this side, right? And so this is like the back of your head, I guess. It's like the back of your head. So it's kind of interesting the way that it would be in that way. I love this area right here, the olfactory, right? So olfactory, deep within the brain, right next to a lot of those like more primitive regions of the brain, right? Even that olfactory nerve is just right sinking right directly into this part of the brain. So oftentimes, visual memory triggers won't be as dramatic, or auditory won't be as dramatic as, say, like just a smell, right? The smell of grandma's lasagna, or the smell of that perfume, right, can really take people back and trigger memories with a lot more strength. And inside this region, this is all going to be like white tracts, or some of the ventricular areas. So the ventricles are going to have cerebral spinal fluid, right? So the drinking water, and unfortunately also the toilet of the brain. Okay, let's keep going on. So let's talk about the idea of lateralization. So we talked about like lateralization, right? So we are symmetrically bilateral, right? So meaning that if you like, you can pretty much get us a mirror image on either side. Oh, it's like not quite the, oh, well, goodness gracious, that didn't go well at all. I'm sorry about that, but you get the idea. So like there's like, a divide down the middle, and it's the same on one side as it is on the other, right? So this is the same for the brain. If you were to see like, looking top down at the brain, right? So here's longitudinal fissure. You would have these association areas, for example, would be on the same sides, right? Occipital would be in the same areas over here, right? And so lateralization divides the labor between the two hemispheres, and it also is protective against things like brain trauma or injury. At least you still have kind of like another area that is preformed to take on similar, if not the same function. So they're similar, but they're not identical, okay? Meaning they actually specialize on their own. Like the platforms laid out but they tend to have a different set of experiences, which obviously there's different sets of nerves over there, and so the wiring does kind of take on its own uniqueness in that way. So cerebral dominance is the idea that there is a hemisphere that is dominant for language. Depending on who you are, it depends on like what it's going to be. Most of the time, humans seem to go on the left-hand side for that dominance, which is interesting. We'll talk about the idea of like Broca's and Wernicke's areas and how they control kind of that relay of speech. But there's if you have, your Wernicke's Broca's area on one side of your brain, it doesn't mean it's not on the other side at all. Actually, it turns out we're learning more, and one of the things we think what happens is we might be more responsible for like singing on the other side of the brain. So they're just a different shade of similar function. So that's something that's really important in recovery after injury, for example. So anyway, this is a trait that I guess is somehow related to right-handedness. I don't know how 100% accurate that is, but maybe it is. And then about 10% at this point in time, they were feeling that the hemispheres would be reversed. So if you like don't have, for example, like Wernicke's and Broca's area on one side of your brain, on the left side, it still will show up somewhere, and that somewhere is going to be on the right side. Okay. So like over time, there was this idea, and I mean, it somewhat may hold true today. And, I didn't specialize in psychology at all, but the idea was based on some evidence at the time that, for example, your left brain would control things like logic and reasoning and all this other stuff, that it was primarily verbal. And then, like, your right side of your brain would be more your artistic side, and there's intuition and emotions, right, and visual. And we're finding that's maybe, but it may also be, for example, right brain or left brain has, areas for speech, right, and understanding and processing speech, but the right brain, does it for maybe, say, music or, other things. So, that's the idea between I don't know personally how I feel about this, and I feel like this part of the field may still be evolving. And I also feel like it's really interesting because, brains have a basic template that we're born with for the most part, like generally as the species, and they fill out and specialize over time in specific regions. But a lot of how a brain develops is very unique to humans' life experience and possibly even concepts like methylation. So it'll be interesting to see that. Let's move on to white matter tracts. The white matter. White matter tracts are communication, like the phone lines of a brain. And if you like look up here, like you can see how much of a brain is just like these like white matter tracts, right? So what these are like essentially like bundled axons in some cases, sometimes not always bundled, right? But they're really actually going like a lot of ways. Like some of them are going, oh wait, there you go. They drew it for me, so that's very nice. Right, some are connecting this part of the brain to that part of the brain, or like this part of the brain to this part of the brain, right? Some of them are connecting this part of the brain to like the body, right? And back and forth. And still others, and you can see here, you can think of it as like if there was like here's a front part of a brain. These are eyes, right? I don't know, what did you have? There's eyes. A little more friendly when you put on eyelashes, right? And smile. Right, there's longitudinal fissure right here. So then these green ones are actually like talking sideways, if that makes sense, like between the hemispheres, like they're lateral. Okay. So the ones that are moving between areas, like more locally, are association fibers, right? So the ones that are talking, more, through the hemispheres, those are the commissural fibers. And you can remember, like, it's a C word. And so, like, there's this big area that is developed, and it's one of the ones that's really fun to do on the dissections. So it's the corpus callosum, right? The body of the Colosseum, essentially, right? Like, not the body of the Colosseum, but of the Colossus. Sorry, it's huge. It's this big old body, and it's like if you're trying to cut through it on your dissections, you really have to move hard because it's a lot of connective tissue tightly wound in there. And then the projection fibers are the ones that are going in and out throughout the body. Okay, so you can talk to your neighbor, you can talk to someone on the other side of the street, and you can talk to somebody down the street. Basically, is how it goes. All right, let's get back in here. All right, cerebral white matter. So again, we have association fibers. They're moving horizontally. They're connecting different parts of the same hemisphere. Commissural fibers, right? So they're also the corpus callosum, right? They're moving horizontally. They're connecting the two hemispheres, right? So they're going back and forth. And those projection fibers are going in and out of the body. They're going long ways, right? So that's what they're doing. And then that corpus callosum is that key structure that is, that key structure that is communicating between the hemispheres of most of those lobes. Wow, it's a good thing I am almost done because, as you saw, my battery is about to bite it. Okay, so I hope you enjoyed learning the basics of some of these concepts, and I hope that helps you get started a little bit more. We'll expand on these in some of our other videos, but for now, I hope this is pretty good, and I hope you have a lovely, lovely morning. All right, bye for now.